Hello everyone, welcome to my channel Coding Together. My name is Vikas Oja. Today we will see another Leetcode problem, that is container with most water. So it's a medium level question and it's a very popular question, as you can see from the likes. So let's read the problem statement first. That we are given with an integer array of height of length n. So there are n integers with integer array of height length n, and there are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height I. So for every line, the first endpoint is the I comma 0. So for if it starts from 0 1 2 3 4, so for this line it will be 4 comma 0, this endpoint, and the another point and endpoint will be 4 comma 5, right, the height of the line. Find two lines that together with the x-axis form a container such that container contains the most water, and return the maximum amount of water a container can store. So if you can think of these vertical lines as a container between any two vertical lines, so suppose this red line and this black line can be think of as a container, and the blue portion is a water contained in it, right? So every two vertical lines can be think of as a container, and we have to return the maximum of amount of water that a container can store. Let's try to see this problem with an example and try to understand what approaches we can take to solve this problem. So first approach that comes into mind is a brute force, right? That comes into mind is a brute force. So suppose we have verticals lying like this. So we can first see all the possible containers, right? If I say this can be one of the container, 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 right, this can be one of the container. So if I apply brute force, there will be order of n square, right? For each line we can have a container with other lines, right? So for each value of I we will have a j, right? So running in a n square loop. For this line I can have a container with this lines. Again with this line I can have container with this lines, and so on. So each line has a container with the other lines that are ahead of it. So if I start from 0 to n, 1 to n, then j will start from 1 plus I to n, right? So it will be a 2 for loops, that is a on square. Like, so is there any possible way apart from the brute force to reduce the time complexity? So yes, we can think of one approach here. So what is the intuition? What is the intuition here is, let's talk about the intuition. So it is obvious that a container with large heights, right, a largest heights and the largest width, like if this is the width between any two lines, and if there is a height h1 and h2, right? So it is obvious that in this condition where heights are maximum and the width is maximum, right, if the heights are maximum and width is maximum, the distance between the lines is maximum, that will have the maximum water stored, right? That will be a largest container to store the maximum amount of water. So what we can have is we can use a two-pointer approach here. Right, we can have a two-pointer approach. So that first pointer will be that the starting point, start line. So this will be our first pointer, let's say I, right? This will be the first pointer, and j with the last pointer, last line, pointing to last line, right? So I will be pointing to first line and j will be pointing to last line, right? Why we are taking two pointers? So that we have the maximum width at least. We have the maximum width at least, because we don't know, because the heights are randomized, right? Heights are at random points, but we are sure of one thing, that if we can start with the maximum width at least, right? And the maximum width will be between the first line and the last line, right? Now we have to start with the maximum width, right? Because the most favorable or the maximum water will be contained in a container which has the maximum heights and the maximum width. So we can start with the maximum width that we know that it will be between the first line and the last line. Now we can go for the larger heights. You can go with the larger heights, right? So right, the first pointer and the last pointer will help in finding the larger heights, right? So whichever the height of the lines, right, either for the first pointer or the last pointer, whichever height is smaller will move our pointer from smaller to larger, right? We'll move our pointer from smaller to larger, because the probability of finding the larger container, like, will be if we move from the smaller heights to the larger heights, right? Smaller height to the larger height. So we'll compare. So once again, the pointer was at the small line and the last pointer was at the larger line. So we'll move our first pointer from smaller to the larger height, because this will give us the probability of finding a bigger container, right? So maybe the width, but we are decreasing the width, but it can be compensated with the increment of the height, right? Because from the smaller one, the area, the water was around this much, right? Now when we increased our height, right, when we saw that the first pointer pointing to first line and the second pointer to the last line, so we moved our pointer from first to second. So we have this much area of container, right? We have this much area of the container. So it might be possible that the volume of the water in this container can be greater than this volume of water, right? So I have represented this example using the line graph, and we will have our variables, the two pointers, that is left, that will point to the line with the height 1. So it is pointing to the line 0 with the height 1. So for left, height is 1, and for right, it is representing a line. It is the last line, that is of height 8, and the current width between the left and the right is 5 minus 0, that is 5. So the current area is 8. The current area is, we have to take the minimum of the left and the right, right? So it will be minimum of left height comma right height into width. So it will be minimum of left and right, that is 1 into 5, that is 5, right? So now as we have uh, talked about, that whenever the line with a height less than the last uh, so so left is pointing this and right is pointing this, right, this line. So the height represented by left is smaller than the height represented by right, so we will move left from 0 to 1 in thin text. So this will be our new left, right? Then this will be the left, that is 8. Now we'll again calculate the width. So width will be now 5 minus 1, that is 4. And we will again calculate the area. So area will be minimum of left comma right. So minimum of left, that is 8 and 8 will be 8, right, into width is 4. So the area is 82 32. Now again we'll check whether which one is left. So these are equal, so let's move left because it doesn't matter, both are simple. So we will move our left, again move our left from index 1 to 2. So our left will represent a line with height 6 and right is at the same line representing 8. So width has now reduced to 5 minus 2, that is 3. And now we'll again calculate the height, that will be the smallest, the minimum of left and right. So the minimum of 8 and 6 is 6 into width is now, that is 5 minus 2 3, that is 18. But area, we will not update the max area to 18, we will not take it because we have already the maximum area 32 available, right? So now again we'll check between 6 and 8. So left is representing the line with smaller height, so we'll again increment it from 2 to 3. So it is representing, it will represent a line with height 2, right? Now we will now the right is at 8. Now we'll again calculate the width, that is 5 minus 3, that is 2, right? And then we'll again calculate the area. So minimum is 2 and 8, minimum is 2 into what is the width, that is 2, area is 4. Again we will ignore it because we have the maximum area. Now between 2 and 8, 2 is smaller, so we'll again update left to 5. So we'll update left to 5. Now the width between 8 and 5, that is 5 minus 4 is 1, right? So we'll again calculate the area. So area will be, what is the smallest between 5 and 8, it's 5 into the width is 1, so area is 5. So we'll again not take it because we have the larger volume or the area of the container available. Now we have to check till left less than right. When we increment left again, it will be equal to right, so we have to break in this scenario, right? So the maximum area available is 32. It was the maximum area available between this container, with this container. So let's see the code part of it. So we have our max area initialized as 0. We have initialized our left pointer pointing the line at 0 index and the right pointer pointing at the line at the last line. And while left is less than right, we'll first calculate the width between the right and the left, between the right line and the left line, and we have to calculate the maximum area. So we'll take the maximum area as the max of max area already stored in the variable and the minimum of the height left and the right, because the water between any two container, right, between any two container, it will be the lowest height that can store the water, because if it, we cannot take the maximum height because it will overflow from the lowest. So it will be the minimum of left and right into width, current width between the lines, and if the height of the left is smaller or than equal to the height of the right, we'll update our left pointer, else we'll decrease our right pointer, right? So idea is to maximize the height, right, and calculate the area. So, and finally we'll return the max area. So let's try to run this program. Let's try to run this solution. So yes, test cases are accepted, so this solution is working fine. So I hope you do like this video, and if you like this video, please share and subscribe. Thanks for watching.